Hi, I'm Dave Dooling, Education Director at the New Mexico Museum of Space History. Welcome to another of our stories from space. Today, we are talking about killer rocks coming soon to a planet near you. Okay, not today, but eventually and in the news this year. In October, NASA will sample an asteroid. In December, Japan will recover its second asteroid sample. Next summer, NASA will launch a probe to nudge an asteroid into a different orbit. And June 30 is Asteroid Day, the anniversary of Earth's biggest celestial collision in modern history. They are all part of the effort to keep humankind from going the way of the dinosaur. Space collisions have been a science fiction standard since Jules Verne's 1877 book, Off on a Comet. A 1933 novel, When Worlds Collide, became famous with a 1951 movie of the same name. And Moon and Mars are pocked with craters, so why not us? Until the 1960s, few scientists worried about it. That was all in the past, when the solar system was new and filled with leftovers. And nothing like that had happened recently, right? Wrong. In November 1833, stars fell on Alabama and the rest of the world, and scientists confirmed that meteors really come from outer space. Still, most burned up in the atmosphere, and the few that hit the ground were small. Like the 11-pound meteorite that plunged through an Alabama house in 1954 and injured Elizabeth Ann Hodges. But there were bigger clues, like Barringer Crater in Arizona and the 15-mile-wide Nordlinger Ries crater in Germany. In 1960, geologist Eugene Shoemaker found quartz crystals with microscopic shock patterns that only form under high pressure, proving that asteroids dug these craters 50,000 and 15 million years ago. A different clue was on the other side of the world in Siberia. On June 30, 1908, something exploded over the Tunguska region and flattened trees for miles around, but left no crater. Word was slow to get out, and access was almost impossible after the Russian Revolution. But now it has become Asteroid Day. Finally, in 1977, a son's gift sent him and his father on a hunt that changed our perception of a benign solar system. Geologist Walter Alvarez gave his father, nuclear physicist Louis Alvarez, a curious piece of clay from Gubbio, Italy. The clay layer contains 30 times more iridium than the soil above or below it. Iridium is so rare on Earth that it comes either from volcanoes or meteorites. Other scientists found iridium across the world, even outside Raton, New Mexico, indicating something big dusted the planet 66 million years ago, exactly when the dinosaurs disappeared. Just a coincidence? The hunt for a smoking gun connected to the search for new oil fields in the Gulf of Mexico. Exploration geologists found quartz with Shoemaker's microscopic shock patterns. This was the Chicxulub crater, almost 100 miles wide and 19 miles deep, big enough to deform Earth's gravity at the edge of Mexico's Yucatan Peninsula. Evidence piled up and led scientists to estimate that Earth was hit by an asteroid about the size of the moons of Mars. And 66 million years is quite recent, less than 2% of the age of Earth. Even the Tunguska event, which was just yesterday, would kill millions and wreck the world economy if it exploded over a population center. Could it happen again? Jupiter answered with a resounding yes. On March 23, 1993, Gene and Carolyn Shoemaker and David Levy discovered a comet that had been captured and then shredded by Jupiter's strong gravity. The team predicted that the comet would soon plunge into Jupiter. For 6 days in July 1994, astronomers were transfixed as they watched 21 fragments of Shoemaker-Levy 9 splash into Jupiter. This gave new importance to work by Dr. Eleanor Helen, who had been discovering small solar system bodies since the 1970s. She organized the Near-Earth Asteroid Tracking Program, starting with Air Force telescopes designed to look for satellites. This led to the Lincoln Near-Earth Asteroid Research Observatory outside Socorro, New Mexico, and others. Soon, everyone was asking, what do we do when we find one headed our way? Not if, but when. In 2002, the B612 Foundation was set up by scientists and former astronauts to raise public awareness. In 2005, Congress directed NASA to hunt and catalog dangerous bodies as small as 330 feet wide. In 2016, NASA formed a Planetary Defense Coordination Office to work with other agencies and governments like the International Asteroid Warning Network. Ground-based observatories like Pan-STARRS and Spacewatch and NASA's Wide Field Infrared Survey Explorer have discovered tens of thousands of objects. The first asteroid, Ceres, at 580 miles wide, was discovered in 1801, and another 9 by 1849. New telescopes revealed smaller and smaller rocks, bringing the total to 100 in 1868, 10,000 by 1989, and almost a million now. Most hang out in a belt between Mars and Jupiter, but scientists quickly learned that many cross Earth's orbit and might collide. More worrisome, comets from deep in the outer solar system often dive through the inner solar system from almost any angle, like comet C 2019 Q4 Borisov. Or they may come from elsewhere in the galaxy, like Oumuamua, a 3,000-foot mystery object that zipped through our solar system in 2017. Each body gets a risk number on the Torino scale. So far, nothing has been rated higher than 4, meaning close attention. 10 is game over. So what to do when a body gets a high number? The most common response is blow it up. That was the answer from MIT aerospace students when they got a unique class assignment in 1967. Asteroid Icarus is going to collide with Earth in a year. What can you do to save us? Their answer was to launch 6 Saturn V moon rockets with 100 megaton bombs to divert or shatter Icarus. Their plan gave birth to movies such as Meteor, Deep Impact, and Armageddon, which helped raise public awareness. But would the damage be as bad as the special effects? Yes. We can't ask the dinosaurs, but we can ask the people of Chelyabinsk, Russia. On February 15, 2013, a 66-foot wide asteroid blazed through the atmosphere 15 miles up at 42,000 miles an hour. Suddenly superheating 22 million pounds of space-cold stony asteroid made it shatter and explode like a half-megaton H-bomb, shattering windows and scattering debris like this 134-pound nickel-iron hunk in the museum's collection. This one is part of a 135-ton asteroid that fell on Campo del Cielo, Argentina, just 4,000 years ago. Imagine if a body like Chelyabinsk plunged straight into a city or splashed into the ocean. How would you save the world? It depends. How big is the asteroid? How long do we have? What's it made of? The last question led to multiple space missions to study asteroids up close and personal, and even bring some pieces home. Galileo was first, snapping pictures of Gaspra in 1991, and then Ida and Dactyl in 1993 on its way to Jupiter. We have landed on 433 Eros, orbited Vesta, and Ceres, landed on Comet 67P Churyumov-Gerasimenko, and sampled asteroid Itokawa. Japan's Hayabusa 2 should parachute into Australia in December with samples of Ryugu, a half-mile wide hazardous asteroid. NASA's OSIRIS-REx probe will sample Bennu in October, then head home. The double asteroid redirection test will launch in July 2021 and slam into the moon of Didymos to see how much its orbit changes. Some adventurers even talk about mining asteroids for iridium and other precious metals that are so rare on Earth. They would use mass drivers, basically electric motors that work in a straight line, like the Navy's new catapults, to fire blocks of material into space. But what can we do once we know what we are facing? Nuking is still an option. It would work best if the asteroid is a rubble pile that is easily shattered into small pieces that would go their separate ways or burn up on entry. Zapping a solid asteroid with a laser would boil away surface material that becomes a thruster, redirecting the asteroid. We don't have tractor beams, but we could build a tow truck. A heavyweight spacecraft could use its own gravity to gently tug the asteroid off course. Or we could paint it to change how it absorbs and re-emits sunlight and heat. This uses the Yarkovsky effect, which actually makes asteroid orbits slightly chaotic. Or we could push them out of the way. The action-reaction from a mass driver would also make the asteroid recoil in the opposite direction. We might even use an asteroid to save Earth. As the sun gets older, it gets brighter. In a billion years, it will be 11% brighter and boil away the oceans and atmosphere. Well, before then, we should have figured out how to redirect asteroids to slowly tug Earth away from the sun. It would be a delicate ballet, using gravitational assists like the ones that help direct space probes across the solar system. Thousands of bodies would cycle back and forth, stealing momentum from Jupiter or Saturn and giving it to Earth. Each near miss would slowly raise our orbit around the Sun. About 1 million encounters would do the job. There's no rush. We have the next 100,000 years to get it funded. If we survive the ultimate game of Dodge Rock.